This week has been a bit busy. That's why there was no video this Friday. But I thought I'd show you a bit what I've been working on the continuous integration system. So let me get these clothes off and I'll see you at the computer. Okay, so first of all, I've created this repository on my GitHub page called RLCI, and it states that this is an experimental CI/CD system designed to solve problems I've had with Jenkins. So I've started to prototype a pipeline language, like a language for writing pipelines. And my dad submitted some samples how you can do job control. I haven't really looked at this, but I will probably do that soon. So in this video I wanted to show you the pipeline language. So let's switch over to the source code and let's have a look at the pipeline language. So we have a few things. We have a make script, we have an example pipeline, and we have the pipeline language definition itself. So let's open up the example pipeline and also let's open up the pipeline language definition. So let's see. So here on the left hand side, this is like a prototype for how you write pipelines. So as I had in my notes, you can see the sequential block here and the parallel block here, and you also have stage blocks. And these can be, the sequential and parallel blocks can be nested arbitrarily, and inside of them you have stages, and stages like the atom in the pipeline. And down here there's also a syntax for creating more arbitrary links. So here, for example, we name this stage from the side, and we also name stages foo and bar here. And then we say make a link from the side to foo and from the side to bar. So if we run this, let's see, run the make script. This pipeline definition will get transformed into a dot file, which is then displayed with Dotty. So let's have a look here. So this is all the pipelines that are defined in this example pipeline file. So here we can see this from the side, which has links to foo and bar, and so this is the example pipeline where sequential and parallel blocks are not enough to create this kind of pipeline. I'm not entirely sure when this will be useful. I think sequential and parallel blocks will cover most of the pipelines, but I think we need the flexibility. We need a flexibility of the underlying data structure being DAG. So what to show next? I can also show you that in here there is a way to create a template. So here is a template that creates two stages in sequence, and the first stage simulates a checkout and the repo name comes as an argument, and then this template can be called down here with two different repo names, and it will yield two different pipelines. So that's kind of a mechanism for reuse in this pipeline language. So I've been playing around a lot with the syntax. Right now it's a custom language. I'm not sure if it will be or if we'll do something else, but it gives me a framework to think about, like a structure of the language, and to think in terms of these sequential and parallel blocks without being distracted with like Python syntax or something else. So I can show you how this is implemented. So this is all written in RL Meta. So there are a couple of grammars. First, we have the parser, then we have the toDAG, and then we have the toDot grammar. So the parser basically reads this whole file and creates AST nodes with parallel and sequential blocks, stores templates, links, and all that stuff. And at the end of it, this toDAG grammar is run, which basically converts this AST to a DAG, which is a list of nodes and a list of links. So when this translates quite well to the dot format, where a node is just written like this, so the ID, and then we have the label, and then links are written like this. So this is the internal representation which is drawn here. So yeah, that's how far I've come. And I said in a previous video that I wanted to explore visualization of these pipelines, and I kind of started in a different end and started with this pipeline language to flesh out like the structure of everything. Perhaps this is also a syntax that will be used later on. And then I just used GraphViz to visualize the pipelines. So this, not sure, maybe it can be used for rendering to the web as well. We'll see. But for now, I'm a little bit more interested in fleshing out this pipeline language and figuring out what primitives should be and how to combine them, stuff like that. So working on the syntax has been really fun, and I plan to continue to do that. So let's see, I have a to-do here. So next thing that I want to work on is probably to flesh out stage input and output syntax. So the idea is that for all the arrows here that you see, a stage should be able to pass output arguments to the next stage. And it should also be able to read arguments that was passed from the previous stage. So I want to flesh out that syntax to see what that would look like in this language. And I think one good way of doing that is to create like a realistic pipeline for something that I would like to use. I mean, I call this example realistic. I'm not sure that it is, but try to like build a simple pipeline for something real and figure out how can I write it in this language where it will perform a useful task, and yeah, instead of just using toy examples. So in the beginning I was just interested in getting this the parser and the toDAG conversion to work and seeing that the pipelines looked correct, so I just created arbitrary structures. But now I think it's time to create some real structures and seeing what kind of information needs to be passed between stages and how to stitch that together with the syntax in the pipeline language. So that's probably what I'll work on next. So perhaps next week I can show you some more progress on this system I built. But until next time, bye.